has nothing to do with story.
Okay, so the example we are starting with.
Wow.
If vector 1, or if our vector, equals 6, -4, find 2 times that vector. Can you move it?
It almost feels like we were in here yesterday.
Because we weren't. That was the point.
Come in.
So how am I going to find 2 times v if I know what v is?
So
Well,
multiply by 2.
Put 2 in front of the whole thing.
I'm going to put 2 in front of the whole vector point,
Oh no.
and then I'm going to multiply it in to get my new coordinate.
It says that every time I open it barely.
So 2v is equal to the 12, -8.
Oh, yeah.
Does that make sense?
Yes.
So we just multiplied that in.
I'm so confused where you
That's
guys
pretty easy, but now we have
I'm good now.
Yeah, that's not come off.
Now we
Okay,
gotta
go.
do something. Now we gotta.
Next one.
What? I thought there was more we had to do. Oh, no, just this one. Okay, where's the difference?
What kind of a bracket is that?
Okay, so when we're given a vector, we are sometimes given that vector in these triangular brackets instead of a parentheses. It still means the same thing. It still indicates that what is inside is a vector coordinate. It doesn't change anything. So if I'm trying to find 1/2 of v, yes, Zach.
Probably put it over 2.
Probably put it over 2. And by it, you mean each of the coordinates of my vector, correct?
Of course.
Of course. So 1/2 v is going to equal 1/2 multiplied into both coordinates in my vector, which becomes each of my coordinates over 2, and then simplified if possible. So my new vector is equal to -3/2, comma 2. I prefer that we leave it as a fraction instead of trying to turn it into a mixed number or a decimal.
What? What if we're given like those different brackets, but we just use this like the normal ones?
That's fine. That's fine. Questions, concerns, or issues so far? No, we're okay. So let's do another one.
Is this the rest of the lesson?
No. This will be the last one that we do.
Are we gonna finish those today?
Yes.
Yeah, this is the half. We don't have it. It's probably like third quarter.
3B. Wind.
So this time I have 2 vectors, v and w. Vector v is equal to 4, 2. Vector w is equal to 5, -2. And I would like to find -3v minus 2w.
Oh my God.
It's exactly like the previous examples, except now we have 2 vectors that we're multiplying a scalar into, and then we're doing their difference together. So this is equal to -3 times my vector v, which is 4, 2, minus 2 times my vector 5, -2. So I just replaced v and w with the coordinates of its respective vector. We'll distribute them in, and then we will simplify. So this one equals -12, -6, minus 10, -4. Huh? So I took,
-10, +4.
okay, there are 2 ways you can look at this. I'm choosing to keep a subtraction in the middle. So I just took the 2 and multiplied it into both of them. You also could have chosen to multiply the -2 in, and then this would become a positive. It is your choice. Just make sure you are consistent. So I chose my way so we preserve the subtraction portion of this. If you distributed the -2, you need to change this to addition. And then what do we do from here if I'm adding or subtracting two vectors?
You use the rule.
Combine like terms. So we're going to put our x's together and we're going to put our y's together with this operation. So this becomes -12 minus 10, comma -6 minus the -4, which gives me -22 and -2. Everyone okay so far? Anybody confused by what we just did? Does that kind of make sense? Okay. So what we have next is called our unit vector. This is a special kind of vector with a couple very unique characteristics that we're going to go ahead and write down. So the unit vector has a magnitude of 1. And is a scalar multiple of our vector v. So what this means is if I have a vector v and I want to find the unit vector, so that would be vu, this is equal to 1 over the magnitude of v times vector v. Another way of writing this is that this is equal to vector v divided by its magnitude. Of course, we're going to do an example of what this means so that you can see an actual numerical example. But this is the basically formula for finding a unit vector. So the example we're going to use,
Can I just put this in my calculator?
no, is given vector v equals 6, 4, but like when we do the magnitude you can, but not in general, not the whole thing. If given vector v is 6, 4, find the unit vector of v. I use VU to denote a unit vector just so it looks different than normal V. So VU here is going to equal my vector 6, 4 over the magnitude of my vector V. So I'm going to have to find that magnitude before I can actually do this. How do I find the magnitude of a vector? The square root of x squared plus y squared, where x and y come from the coordinate. So this would be the square root of 6 squared plus 4 squared, which becomes the square root of 52.
16, 36, 50.
Right, 52.
16 plus 32.
Yeah, it's 52. Okay. So my magnitude here is 52.
But you want a decimal?
No, I want it left as the radical there. Because we're going to turn into a fraction and we don't want a decimal in a fraction. So now I go back to my unit vector example. That means that my unit vector is the vector 6, 4 over the square root of 52, which means I take each of these coordinates and I put it over the square root of 52 and that becomes my new vector. So then this is equal to 6 over the square root of 52, comma 4 over the square root of 52. And then that would be my unit vector.
That's the answer?
That's your answer. Does that kind of make sense?
Yeah.
Is anybody super duper confused by that? Except for Jerry, he doesn't count.
No, but I'm super
Now-
blind. Can you?
Yes.
Now, do you always want us to keep it as a radical?
Yes. If it doesn't come out to a nice whole number, it will stay as a radical. For a unit vector, yes. If you're just finding magnitude, I'm fine with the decimal.
So it's V over absolute V? Got it.
V over magnitude of V. Yes. Any questions, concerns, or issues on that?
Very easy.
Okay, so now we're gonna start talking about the dot product of two vectors. So we've done addition, we've done subtraction, we've done scalar multiplication. Now we're going to look at dot products.
I did this back in second grade.
Okay, so your dot product is written out as our first vector, close dot our second vector. So now when we are doing multiplication of vectors, that is different than dot product of vectors. So you need to be very careful. Anytime you see a closed dot between two vectors, that indicates dot product, not normal multiplication. So when I am dot producting two vectors, no, they would put a little x for multiplication. Yeah, there's a very big difference right now. I know we've in the past used a closed dot for multiplication because when we use x's, they are variables. For vectors, it's different. Closed dot only means dot product. So what this is, it is x plus x. Oh, sorry, x times x. Oh my gosh. Plus y times y. And it is just going to be one number. So our dot product comes out to be one number. It is x times x plus y times y. So we're still putting like terms together. This time it's with multiplication and then adding their products. So of course we're going to go ahead and do an example. So for our example, we're going to assume we have two vectors. The first one is vector v, which is 6, 4. And vector w, which is -1, 2. And I would like to find v dot w.
Okay, question.
Yes, ma'am.
On the homework and stuff, will it always be a V and a W?
No, it could be x, it could be z, it could be a, it could be b, it could be whatever. V and w are just our most common when we talk about vectors. So when I'm doing my dot product, I multiply like terms together. So I'm going to start with my two x's. My two x's are 6 and -1. So I'm going to have 6 times -1 plus, then I'm going to put my y's together, which are 4 and 2. I'm going to go ahead and do the multiplication. 6 and -1 is -6. 4 and 2 is 8. So my dot product is 2.
Why is the dot product the easiest one?
It just is.
And it looks the most complex.
I know, right? It is not. It is literally the easiest thing.
So explain the open dot and the.
No. So if they want vector multiplication, it'll be a little x, like normal multiplication sign. If they want dot product, it will be a closed dot. So there's a huge difference between a closed dot and just normal multiplication.
Closed dot is.
Dot product, only for vectors though.
Okay, so there is not going to be an open dot.
There will not be an open circle when we talk about vectors.
Okay.
That is simply composition of functions. That's way back.
When you said like the closed dot, I was like, is there going to be an open
No,
dot?
there is not an open dot. There's just a closed dot. You just need to know the difference between v dot w and v times w. There's a difference between these two. Okay?
Okay, but doesn't it do the same thing?
No, it does not.
Are we going to learn that?
No, we're not. Which brings me to my my most favorite part of dot product, and that is orthogonality. That's a fun word, right?
Orthogonality.
Orthogonality.
Orthogonality. Yeah, spelling bowl competition right now.
You know I'm the spell ball coach, right?
Exactly.
Wait, say it again.
Orthogonality.
Us.
O-R-T-H-A-G. Wait, orthog.
Orthodontist.
THOGANOLOGY.
Wrong. Like, I do so bad, I can like picture words in my head too. Orthogonality.
Probably starts with an O.
This is how I spelled it. I need you to spell it.
I'm going to in a second.
So it's 4 times.
When is spellable? Like, when did that happen?
It happened already, it was in the fall. If two vectors have a dot product that equals 0, they are said to be orthogonal. Another word for orthogonal is perpendicular. So orthogonality means that these two vectors run perpendicular to each other.
Starts with an O.
Orthogonal. O-R-T-H-O-G-O-N-A-L.
So the way a question like this would be posed to you is it would give you two vectors and it would ask you to determine whether or not they are orthogonal to each other. So that's how we're going to run our example.
I spelled it right.
I said they were parallel.
No, orthogonality means perpendicular.
I could have sworn.
I don't think so.
I also.
Well, we know now it's.
Yes, we know now. Okay.
Maybe I'm tripping.
Guess who's gonna come in 2 hours?
For what? Where?
College,
For what?
special education.
I already beat you to that race, Kennedy.
School, don't care.
So if it equals, we just say we're talking.
With Billy
Yes.
Wins. And Rob told me.
Why does it sound so intimidating?
I don't know, just us. Okay, so for this example, I've given you two vectors, v1 and v2, and I have asked you to determine whether or not they are orthogonal. So what do I have to find to determine orthogonality?
It equals 0.
Dot product. I have to find the dot product. So that's what I'm going to start with. I'm going to have v1 dot v2, and that's going to equal x times x plus y times y, and then I'm going to put my products together. Did I get a dot product that equals 0?
No.
No. So the way we say this is we say they are not orthogonal. Because 14 is not equal to 0.
I just put cuz, like.
Does like C-U-Z?
Yeah.
Sure, I don't care.
Okay.
Yes.
Cuz 14 equal.
Does not equal 0.
The orthogonal,
Yes.
is that always supposed to equal 0?
Orthogonality is determined by a dot product that equals 0. Yes. So the only way to be orthogonal is if they have a dot product equal to 0.
I feel like this is gonna be great.
So weird.
This is a wonderful test question and quiz question and pop quiz question. I mean, so many opportunities.
Don't even start with the pop quiz.
So there's one more thing that we are going to do, and then we are finished. No, it's not a pop quiz.
Why I just hear us as if you're doing this whole lesson?
I didn't.
You done got us messed up.
Is everybody okay with the orthogonality part of this?
Absolutely.
Are we done?
Is everyone okay with dot
Give
product?
it a 4 now.
Okay, I'm gonna ask 1 to 5. How do we feel so far? 1, you have no idea what you're doing. 5, you could show somebody else how to do these types of problems.
5.
How do we feel?
I can't.
About
Steven, Maddie.
title or the whole thing?
Whole thing so far.
Well, I didn't see them.
3, okay. We have one more part, and that is finding the angle between two vectors.
Really do.
We haven't done that in a while.
How many pages of notes did this take up for you?
About 20.
But I space things out a lot.
Mine took about 3. What's this? Well, one front, one back, and one hood.
Yes.
Good for you.
1, 2, 3.
I'm good with one.
Sir, pepper management,
2.
So the equation we're going to use to determine the angle between two vectors is cosine of theta equals the dot product of my two vectors over the product of their magnitudes. Don't worry, we are going to do an example. This is honestly the hardest that it gets for vectors. This part right here.
It doesn't look that bad though, because
It's not terrible.
magnitudes are easy to get.
Speak for yourself.
This one might just be a
Speak
little
for
lengthy.
yourself.
This one might be a little lengthy.
What was that top, the friendly with two vectors?
I should have to start a whole new page for examples. That's frustrating. Frustrating or frustrating?
Frustrating. There's an R in there.
That's frustrating. Sumner, you look beautiful. I know you can get so beautiful, Sumner.
Okay, so for our example, we're going to be finding the angle between the two vectors v and w, where v is equal to 2, -1, and w is equal to 8, 6. We're going to go ahead and write out the whole thing first, and then we'll solve it by part. Well, I'm writing it right now as well. Okay, so this is the equation that we use. Cosine theta equals dot product of our two vectors over the product of their magnitudes. Here, instead of v1 and v2, I have v and w. So this is also equal to v dot w over the magnitude of v times the magnitude of w. So what 3 things do I need to find in order to complete this problem? Dot product,
Motivation?
magnitude of v, and then magnitude of w. So I have to find those 3 things before I can continue.
Alright, let's start with the.
I agree with that.
Motivation 2, I get that. Okay, we're gonna start with dot product v dot w. How do I find the dot product between two vectors?
Look at their points.
X1 and X2 multiplied plus Y multiplied Y.
X1 and X2 multiplied together plus Y1 and Y2 multiplied together. So here that'd be 2 and 8, and then -1 and 6. This gives me 16 and -6, which gives me 10. So my dot product for these two is 10. So that's what's going to go on top. Now I'm going to find the magnitude of v because that one comes first in my denominator. How do I find the magnitude of v?
The square root of x squared plus y squared.
Awesome. Devin can't answer anymore. So this is going to be the square root of 2 squared plus -1 squared because that was the x and the y for my vector v.
Oh, this calculator real quick.
Remember, we probably want to leave it as a radical if it doesn't come out to a perfect number. When I did it, I got the square root of 5. Does that make sense?
I'm doing darn diddly messed up.
Does everybody see how I got the square root of 5?
Sure.
Yeah, but do you have to keep it a square root of 5 or can you do it?
We're going to leave it as a square root of 5 here because it's going to work out nicely that way, and I prefer you keep it as a radical, unless it comes out to a whole number.
I want some.
Okay, so I'm going to replace the magnitude of v with the square root of 5 that it is equal to. Now, what is the last part I need to find? Magnitude of W. Same process, but instead of 2 and -1, I'm using 8 and 6. It is 64. So we'll give everyone a second to work through this.
Root 5 of 6.
Give everyone a chance to work through this. Did we all get the square root of 100, which comes out to 10?
Why
Yes.
don't you leave it though?
What do you mean?
I left it in the square root form.
If it doesn't simplify to a whole number, we do. So the square root of 5 is not a whole number, but the square root of 100 is. Yes, Jerry.
Can't the top and the bottom cancel?
Okay, so once we have it written, so this is 10 over square root of 5 times 10. We notice that the 10 and the 10 cancel, right? Because if we have something in the top and bottom, it cancels, which means this simplifies into 1 over the square root of 5. So this is what I'm plugging into my calculator to get the decimal for.
So cosine.
So we have cosine of theta equals, and I want the decimal for 1 divided by the square root of 5.
0.4472.
0.99999. Am I tripping?
You're tripping.
I'm not.
0.447.
Awesome. I got 4472.
I got it there.
Then do we round to the nearest?
Cosine,
Try
right?
it again. Hold on. No, I want 4 decimal places for this.
Cosine, right?
Do not plug it in. There's no theta. You are literally just doing this part. You are just doing 1 divided by the square root of 5. No. 1 divided by the square root of 5 will work.
Sounds like, okay, I gotta put in cosine.
No. It's just an angle, yeah.
Okay, 0.447213596.
Did everybody get 0.4472? If not, we're going to pause.
I got a syntax error.
Wait, how did that?
Bro, just type in 1 divided by 2.
You literally type in 1. I got square root 9.
You don't put cosine, though.
Yeah.
No cosine, just 1 divided by the square root of 5.
Stop. I'm gonna
Then you do opposite of cosine to find
No, shh.
your angle.
Well, yes, but no, not yet.
It's actually called inverse.
Yeah.
Did we get 0.4472?
How bad?
Absolutely.
Yes. Anybody confused? Please, please, please. Is anybody confused?
Please say no.
No, none of us are.
Did this answer my question?
No, absolutely not.
No. My question was, what was the angle between the 2 vectors? So I have a trig function, and I have what the trig function is equal to, and now I need to solve for that angle theta. How do I do that?
You have to do the inverse.
What mode should my calculator be in? Degrees. All of our angles between vectors, we're going to calculate in degrees.
Nearest whole number, yeah.
Nearest whole number. So I'm going to do cosine inverse of 0.4472, and that's going to give me my angle theta, and we're going to round to the nearest whole number.
69.
I did it.
I don't want your life.
This isn't even like really hard.
It's just a lot of work for nothing.
This one's really the only one that has a decent bit of work.
So if you were to formally write out the answer here, we would say the angle between vector v and w is 63 degrees.
This is the most work I've ever done for
Does this make sense?
Absolutely.
No, like, I'm really just asking, does this make sense seeing it?
I'm really so
Yes.
But yeah, makes sense.
Okay, your homework is on Canvas. It is a couple of pages, and I did put at the top what numbers I expect you to do. And it is due on Monday.
Can I go pee pee?
She's
I'll take your calculator.
No, you can't take a calculator.
Oh,
Do you not have a black calculator?